A very good morning to all of you. I, Ariman Mahapatra of Group 8, will be presenting you a PPT presentation on transformers with my fellow teammates. The members of my group are Ashay Mishra, Ayandeep Datta, Dibyaranjan Mohanty and Rishita Jha. Now, let's have a brief introduction on transformers. A transformer is a passive component that transfers electrical energy from one electrical circuit to another circuit or multiple circuits. Now, let's have a general idea of its working. A varying component of current in any coil of transformer produces a varying magnetic flux in the transformer's core, which induces an electromagnetic force across any other coil wounded around the same core. Now, after the working, now it's the time for application. Transformers are used to increase or decrease AC voltages in electrical power applications. They are also used in couple stages of signal processing circuits. The next slide is for the power transmission system using transformer. Now I would like my friend Ashay to continue with the construction of transformers.
Thank you everyone. Myself Ashay Mishra and my roll number is 2130015. So let's start. Basically, a transformer consists of two inductive windings and a laminated steel core. The coils are insulated from each other as well as from the steel core. A transformer may also consist of a container for winding and core assembly called as tank. Suitable bushing to take are the terminals, oil conservator to provide coil in the transformer tank for cooling purposes, etc. The figure at right illustrates the basic construction of a transformer. Transformer laminated steel sheet shapes in all types of transformer. Core is constructed by assembling stacking laminated sheet of steel with minimum air gap between them. To achieve continuous magnetic path, the steel used is having high silicon content and sometimes heat treated. To provide high permeability and low hysteresis loss, laminated sheets of steel are used to reduce eddy current losses. The sheets are cut in shape as E, I and L to avoid high reluctance at joints. Laminations are stacked by alternating the slides of joint. That is, if joints of first sheet assembly are at front face, the joint of the following assemble are kept at the back face. The next slide is about the types of construction of transformer. The first type is core type transformer and the second type is shell type transformer. Now I would like to call my friend Ayandeep to explain these two transformers. Ayandeep, please.
Thank you, Ashay. I am Ayandeep Datta. My roll number is 21316 and I'll be describing both types with the differences between them. So a window is the vacant part of core. Core type transformer has only one window, where the shell type transformer has two windows. In core type, winding encircles the core, but in shell type, the core encircles the winding. In core type transformers, the windings are separate and cylindrical windings are done, whereas in shell type transformers, windings overlap and sandwich type winding is used. In core type transformers, repairing is easy as primary and secondary coils are separate, while in shell type it is not so, as both coils are wound together and need to be dismantled. As coils are separate, more surface area is exposed. Due to this, better cooling is possible in core type transformers and this is not so for shell type transformers. Now I would call upon my friend Divya to continue.
Hi, this is Dibyaranjan Mohanty and my roll number is 2130017. Now I would like to talk about the principle of transformer. The primary winding is connected to the single phase AC supply and arc current starts flowing through it. The AC primary current produces an alternating flux in the core. Most of this changing flux gets linked with the secondary winding through the core. The varying flux will induce voltage into the secondary winding according to the Faraday's laws of electromagnetic induction. Voltage level change but frequency, that is time period, remains same. There is no electrical contact between the two windings, and electrical energy gets transferred from primary to the secondary. A simple transformer consists of two electrical conductors called the primary winding and the secondary winding. Energy is coupled between the windings by the time-varying magnetic flux that passes through both primary and secondary windings. Now I would like Ayandeep to continue.
Thank you, Divya. Now coming over to the question, can transformer operate on DC? So the straight answer is no. The transformer action does not take place with the direct current of constant magnitude, because with a DC current, the flux produced in the core is not alternating but is of a constant value. Hence, there is no change in flux linkage with the secondary winding. Hence, the induced EMF in the secondary is zero. If DC is applied to the primary, then there is a possibility of transformer core saturation. If the core saturates, the primary will draw excessively large current. Therefore, application of DC should be avoided as far as possible. Coming to the types of transformers, transformers can be categorized in different ways, depending upon their purpose, use, construction, etc. Note that sometimes these classifications overlap. Example, a transformer can be both a three-phase transformer and a step-up transformer at the same time. The types of transformers are as follows: step-up transformer, step-down transformer. Step-up transformers convert the low voltage LV and high current from the primary side of the transformer to the high voltage HV and low current value on the secondary side of the transformer. Step-down transformers convert the high voltage HV and low current from the primary side of the transformer to the low voltage LV and high current value on the secondary side of the transformer. Now I would call upon my friend Rishita to go with the presentation. Rishita, over to you.
Now I'm going to open the question for improvement of transformers. Regulating alternating current. All transformers have one basic function: increasing or decreasing alternating current within the electrical system. By regulating the flow of current, the transformer allows the increased energy efficiency, which regulates and ultimately lowers electricity bills, stopping and starting the flow of electricity. Transformers are also useful in stopping the flow of electricity and interrupting an electrical current. Transformers are commonly present in circuit breakers, where they utilize the switch to automatically interrupt the flow of electricity and to prevent damage that can occur as a result of high voltage. Battery charging. The concept of battery charging is fueled by the functioning of generators. Transformers are used to control the voltage that enters the battery during the charging process in order to prevent any damages that can occur to the internal battery component. Steel manufacturing. Steel manufacturing plants rely on the functioning of high voltage transformers to provide a range of voltage for the manufacturing process. High currents are required during melting and welding of steel, and lower currents are required during the cooling process. With this, we reach to the conclusion of the PPT, which is a method could possibly be used for the transfer of electricity across the country via the power line. The circuit was not supplying the most efficient or maximum efficiency due to the core losses not equaling the copper losses. So, if you increase the voltage out, then the current out must decrease. If you step up the voltage, so that voltage output is double the voltage input. Thank you.